Hey everybody, my name is Mike Malone, and today we're going to talk about web shells. First, let's talk about what a web shell is. A web shell is essentially a web server-based implant that an attacker can control over the web protocols normally exposed by that web server. They're typically written in web languages. They don't have to be, but you're normally going to see them written in PHP or ASPX. They need to be an active language because they need to be able to run some sort of a server-side code. So let's go ahead and learn a little bit about web servers so we understand how a web shell works and how the vulnerabilities and risks play into how your web server is configured. This is an IIS box running on Server 2022. The only real changes I've done to it is I've installed the ASPX content support, which will let us run ASPX code. I've also added a couple of pages I developed in Visual Studio. So this is the IIS manager, is how you manage a web server, an IIS server specifically. And it's worth noting that the concepts I'm talking about here are going to be slightly different, unlike an Apache box, but they're going to differ slightly in how they're implemented. The object names will be different, etc. You're going to see we have a section here called default website. If you install IIS, this is essentially where the default web pages that get deployed with the web server are stored. You have a bunch of configurations under here. The biggest thing you want to pay attention to here, I would say, is under advanced settings. You're going to notice that this is going to, by default, publish content from the system drive inetpub www root directory. Now, a web server works sort of like a script engine, if you will. It essentially will run whatever a user requests from these folders if it's a supported extension. So it's important to note where these folders are. These are what are called web publish directories, and they're where your potential web shell might exist. The other important thing to pay attention to is the application pool. Now, this is the default app pool, which is the one that comes out of the box with IIS. This is going to be, among other things, the identity of the web server. So anything that is run from this www root directory or any subdirectories thereof are going to be run using the identity associated with this app pool. So let's go ahead and talk about that real quick. So if we go back to application pool over here, you can see we have a default app pool and we have advanced settings. Now, by default, you're going to have application pool identity listed as the identity used for this website. Now, if you've been an IIS admin before, you're going to be familiar with an account type called an iUser account. iUser is essentially the default sandbox accounts that IIS is going to use to run code to make sure that it doesn't break out and do all kinds of bad stuff to the web server. Let's take a look at its permissions real quick. So we're going to go to our directory here, www root. I'm actually going to go up one level, right-click on www root, hit Properties, and go to Security. In here, you're going to see IIS iUsers. This is essentially a local group that contains all of the iUser accounts, and it only has read and execute, list folder contents, and read. It can't really do a whole heck of a lot. This is one of your protections against web shells, because in order for an attacker to use a web shell, they have to write something to a web published directory. This is going to make it so that your web applications, by default, cannot write to a web published directory. In this folder, you're going to also notice that you have www root. You're going to have a default.aspx that comes with IIS. You're also going to have this one I added here called upload.aspx. I've baked a vulnerability into this page. Upload.aspx does not check what the extension of the file is that you're trying to request, and it writes it to basically to whatever directory its current operating directory is. Translation, inetpub www root. This means it'll take whatever I upload and put it right in that web published directory. So let's go to localhost /upload.aspx. Now, first, we're going to go ahead and try this with the limited account that we have. So choose File. I'm going to choose hello.txt, open, and I'm going to hit Upload File, and we're going to get an error. Access to the paths, inetpub www root, hello.txt is denied. Now, here's one of the challenges you run into with web servers. Admins hate this kind of stuff. They hate troubleshooting proper permissions. Developers sometimes assume they're going to have permissions. So the right thing to do is, well, first off, determine if you're supposed to be writing to that directory. If you are supposed to be writing to the directory, you can change permissions to allow you to write to that directory on the folder. But we're going to go ahead and do what I've seen a lot of admins do, and they're going to change the identity of the app pool to run as something more powerful. So under this identity here, we can hit the ellipsis. Now we can change this from the application pool identity to run anything all the way up to local system. You can also use a domain account. Now this is important because if it's running as a domain account, Anything run by that web server might have authorization to other systems throughout the enterprise. It also could be a domain admin, in which case you can go straight from a web-based connection straight to having full domain admin permissions for execution. So we're going to go ahead and set as local system, hit OK, and I'm going to run a command here called IIS reset. So IIS reset essentially restarts the web server. That'll let it take on its new identity. That being done, we're going to go ahead and close this out, and we're going to start up a new session completely. This time, we're going to choose the file, hello.txt, hit open, and upload. And you're going to notice we didn't get an error this time. If I look into our www root, there's hello.txt. Now, hello.txt is not really threatening from a web shell perspective. If I go to hello.txt, it's just going to say hello world. It's going to echo back to me what the contents of that file are, because it knows .txt is not a supported web content extension. So it just basically reads out the content of the file. It downloads the file and displays in your browser for you. Hello.txt wasn't all that particularly risky. It's just a text file. It's handled by the browser. It's just not really going to run any code, if that makes sense. Let's change this up, though. This time, instead of uploading hello.txt, we're going to go ahead and upload an actual web shell, a little basic ASPX web shell you can get on GitHub. I'll put a link to the web shell I'm using in the description below. So let's go back to our previous page. I'm going to choose a different file. And this time, I'm going to go to our downloads and get aspxshell.aspx. Upload this file. Same thing happens. Now, there's a couple very important notes here. I've configured this particular box to not do any AV scanning of the web content directory. And we'll get into that in a little bit when we talk about protections. You'll see it's right here, aspxshell.aspx. And to make things a little bit easier, I'm going to go ahead and just get rid of this space. It'll technically work without it, but it'll be easier for me to demonstrate this way. So we're going to go up here, and instead of asking for upload, we're going to ask for ASPX shell. Okay, so we've got our web shell up. This is a pretty basic web shell. It's got common functionality you'll find in a lot of different web shells. First thing, and most importantly, is you have the ability to arbitrarily execute commands. So, for example, I could run a whoami, and what will happen is the server is going to run whatever I put in that box, and it's going to tell you that I'm running as NT Authority system. Remember, our IIS app pool is running as system, so any command I run in here is going to give me essentially whatever I ask for it because it's system. So I can also do dir, get a directory enumeration. We can actually restart the web server if we want by typing in shutdown RT0 if we want at this point. So you can think of it, basically the world's your oyster at this point. You have arbitrary code execution. And the best part from an attacker perspective, it's over your web servers. So that you don't see any arbitrary command and control channel. You see an inbound request, and it looks pretty normal. The other things you have with this particular web shell is you can essentially browse around the system. You can go to the C drive. We can take a look inside the Windows directory. We can upload, download, basically do whatever we want because, again, we're running as system. We can go back to our previous directory there, go to C, inetpub, www.root, and you're going to see we have our hello.txt. If I don't want that hello.txt there, I'll just hit delete, and it goes away. So really impactful here because this means that an attacker can do anything they want with that particular web server at this point. Let's talk a little bit about what makes web shells so heinous. So first, as you can see, I was controlling the web server over, in this case, port 80 or port 443 if it's a SSL web server. So the communication occurs over what looks perfectly normal to the web shell, to the web server. It's an inbound request to the web server where the code is executed locally. So you don't have a command and control address. You don't really have a funny looking executable that's running that you can look for, or a persistence point like a registry key. The persistence point is the file being in the directory. Second, since it's not an executable file, you're not going to see image loads. So if you're looking in your EDR, you're not going to see that ASPX shell is launching whoami. You're going to see the identity of the web server launching whoami, which is a very key point for detection purposes. We're going to go ahead and take a look at a couple of different types of web shells. I'm going to discuss why they're so difficult to detect and some of the ways that you can get a web shell. Web shells are challenging for a number of reasons. As you could see, all I needed to do was copy or basically upload a file to a web published directory with an active web content extension. That's what we did with my little upload.aspx. You can also potentially modify a file in that directory as well. So because most web content is essentially just a bunch of strings, it's a script for all intents and purposes, you could add a line of code to an existing web page. That's even more difficult. And we'll talk about that in just a minute. But if you have the ability to upload an arbitrary file with web extension or modify a file that has a web extension, a web shell is very easy to essentially implant on the box. The second thing you have is you essentially are running as whatever identity that web server is configured to run as. So if that is using a sandbox account, good news is your impact is going to be a lot more limited. It'll be by default able just to read a web published directory. Now, if you've given it, like I did in this case, local system, or even worse, a domain user account, it's going to be able to do anything up to the level of capability of that particular user. So let's take a look at a couple different web shells that are out there. I've gone out to GitHub and I've found a couple of good examples. So this is the one we're using today, the ASPX shell. One of the key things here is looking for any sort of execution. In this case, this is actually nicely commented exec command. You can see in this case, we're essentially going to create a process object, set it up to run cmd wax-c, and then start the process. And then it's going to write back out to the label whatever came back from that particular command, from the standard output and from standard error. They can also be much simpler. In this case, essentially, this is a very simple little web shell, and it's going to look for a specific attribute and just run whatever's in that attribute. The key piece here is this eval Ivan. Eval is the command to basically run a command using JavaScript. It's setting everything up, ultimately leading to running eval on the object they called Ivan. Now, to show you how simple a web shell can be and why they're so difficult to detect, let's take a look at another example. So this one's on VirusTotal. As you can see, it's picked up by a whole bunch of AV vendors. Page language, JScript, eval, grab whatever is in GKG at 2020 with the unsafe parameter. Essentially, what this is going to do is it's going to take whatever command is passed as parameter GKG at 2020 in a post to that website and run it using the unsafe parameter, which means run whatever you brung. So it's a great example of how simple a web shell can be and why if somebody added this into your existing web code, you might completely gloss right over it. This is a great example of why web shells are so hard to detect from an anti-malware perspective. So anti-malware is really good at analyzing binary code, something that's compiled. Very easy to follow from code path to code path because it's stuck to all the requirements to running on, like, for example, an x86 or AMD 64 CPU typically. It's less capable most of the time at analyzing scripts because you can have all kinds of spaces, you can redefine functions, you can do all kinds of weird stuff that doesn't compile down to bytecode or intermediate code. Something like, for example, .NET would be what they call intermediate code. The way that we handle this with things like PowerShell and Windows is we have a feature called AMSI, the anti-malware scanning interface, which will analyze PowerShell and VB script and deobfuscate all that stuff before it executes. We do not have this for things like websites. So if you have for web content, and this is probably in part due to speed. Web content is designed to be run very quickly. Nobody wants to have a slow web page. So I imagine if you put something in the middle that deobfuscates something on something that's designed to handle a large amount of connections at scale, it's probably going to cause a significant performance impact. Now, this is a great time to talk about anti-malware exclusions. By default, in Server 2016 and later, we automatically exclude the inetpub www root and the w3wp.exe process, which is the web server from anti-malware scanning. This means that if somebody was to drop a web shell in those directories or run one with the web server, AV would not be looking at those particular files and looking at the behaviors. So you want to be really careful. There's actually a recommendation out today to remove those. There's a switch you can pass which will turn off those exclusions. In addition, this is something that web admins will commonly do to improve performance. They will exclude scanning of those directories. And my best recommendation is you don't want to exclude the W3WP process if at all possible. If you have to keep the exclusion in place, what I would recommend doing is running a periodic full scan, because a full scan will look at all the web published directories. Quick scans typically only look at auto start points, and web server published directories are not typically considered an auto start point. We're back on our web server. So let's take a look at what a web shell looks like in anti-malware scanning. So if we take a look under the detection tab here in VirusTotal, you're going to notice we've got a whole bunch of people detecting this particular sample. You're going to see ASP/webshell.j. If you look at, for example, we've got generic.webshell.a. So in our case, in Microsoft's case, you're going to see backdoor ASP/chopper.j bang DHA. Now, what this means, so there's a standard format for malware naming called the Caro standard, and what it essentially is going to be is you're going to see backdoor, so is essentially the type. So this is a backdoor type malware. That's an indication it might be a web shell. But what really gives it away in this case is the ASP part. This is the platform. It's telling me what language this particular malware runs on. In this case, ASP, I'm also seeing ASPX. So if you see backdoor ASP or Trojan ASP, something along those lines, it essentially means that it's probably going to be a web shell at the end of the day. If you see one of those in your web published directories, you probably have a web shell. You should definitely start scanning and taking a look at what happened on that particular box. Since we're talking about detection, let's go ahead and take a look in Microsoft 365 Defender and see what the activity we've already performed looks like from an EDR perspective. Okay, we're here in Microsoft 365 Defender's console. Let's take a look at our incidents and see what we got. So we've got one incident, which is comprised of 3 different alerts here. The first one is we're seeing malscript ransomware was detected. Second was possible web shell file and post exploitation activity. And the third one is a suspicious sequence of exploration activities. If we open up one of these alerts, we'll be able to see the context that everything ran under. So the first thing here is you're going to see we've got our system name. This is my default system name for this web server as Windows Server 2022, and everything was run in the context of NT Authority system. If you look at the process tree here, you've got WinInit, services, service host, W3WP. You know, it says default app pool. This is basically all the information about for this particular instance of IIS, the World Wide Web Publishing Service. So this was essentially running as system. The first thing we have here is we've got W3WP created file ASPX shell.aspx. So this is coming up as possible web shell and post exploitation activity. Great example of us uploading a web extension to a web published directory from a web server. So this right here tells me already that either I have an in-house code vulnerability or I've got a vulnerability in one of the platforms on. So for example, if you're running on, say, WordPress or .NET Nuke or whatever, you may be missing a patch or there may be a 0-day available there. The other possibility is you may have something like WebDAV, which is Web Distributed Authoring and Versioning, which enables a web developer to publish content to the website over web protocols. Now, the next thing we're seeing here is we're seeing CSC run. This is the C# compiler. So since ASPX runs .NET code, essentially what's going to happen is it's going to compile the server-side code on that box. Then we're going to see cmd.exe/c who am I. If you remember, that was the first command I ran from the web shell. So this combination of activity right here with W3WP, cmd, waxc, and then something like who am I, most of the time your websites aren't going to need to identify the user that they're running under, and if they are, they're probably not going to use something like who am I. They're going to use a .NET code to figure out what their current identity is. Next thing we have is we're seeing some user discoveries, and we did a dir, so we listed out the directory. So all of this stuff here is a great indication that we probably have a web shell. We could jump to the timeline and see what it looks like from that perspective. Okay. And you can see over here, it's pretty straightforward. W3WP created process CMD. CMD creates conhost. That's the host for console commands. We're seeing CMD creates who am I. We also see we've got defender-detected ransom HTML malscripts. In this case, we actually classified it as ransomware, which is kind of interesting because there's not really a ransomware component. It's really a backdoor capability, but that's the particular signature that filed. Mind you, I have exclusions in place, so it's not going to actually pick it up. This is exactly what it would look like if you were to run web shell activity from a web server. Another great place to look for web shell activity is advanced hunting. So if we open up hunting here and we go to advanced hunting, you could write a number of different queries looking for persistence or execution of web shells. So the first one is we're going to look for file activity where the folder path starts with C inetpub www root. Let's go ahead and do last 3 hours and hit run. What you'll see here is you're going to see that we created ASPX shell and then we renamed ASPX shell to get rid of the space. So this is a great example of looking for somebody copying web content to a web published directory. Mind you, you can put any set of directories you like in this. It doesn't have to be www root. The more important piece here is we should be looking at the identity that did it. So in this case, I'm seeing NT authority system. The process performing it is inetserv w3wp.exe. So now this is a potential indicator that there's something suspicious going on, not necessarily a guarantee that this is something malicious, because I don't know how your web applications run. This is entirely based on, if you had something, for example, like a content management system, this may be somebody publishing content legitimately to a web published directory for users to get to. So keep that in mind as well. Just because we see an active web extension uploaded to a web published folder by the web server, we can't necessarily guarantee that that's malicious behavior. But if you know what your application normally acts like and you see this behavior, that could be an indicator that there's something malicious going on if that is abnormal. The next thing you can take a look at is we can take a look at device process events. And we can look where the initiating process file name is w3wp. If we look at this, we're going to see everything that was executed by the World Wide Web Publishing Service, which, remember, that's going to be the web server's identity, essentially. That's the web server's process. So you can see we've got our CSC, and then we've got two cmd.exe calls. And if we go over here to the right, we're going to see that it ran whoami and dir. These are the commands that we ran when we did our web shell demo. So another great opportunity to look for that. Now, from a vulnerability perspective, if you wanted to report on the identities of your web servers to see if anybody is running as an elevated identity, you can also do things like this. Let's do distinct, device ID, device name, account domain, account name, and I'm going to put this filter back in here where file name is equal to w3wp.exe. Now, if this was a larger enterprise, you'd be able to see all the different instances of IIS and different identities they're running as. So in this case, you're going to see that initially we were running as the default app pool identity, but then we changed it to NT authority system. So if you have hundreds or thousands of web servers, this is a pretty quick way to get an audit across everything of who is running using what permissions. There are also ways you can identify potential web shell activity by looking at logs on the device itself. The IIS logs, or the W3C logs as the standard they go by, have a lot of information that could indicate potential web shell activity on a web server. Let's take a look. We're back on our web server. This time we're going to go to inetpub and logs instead of the www root directory, and then under log files, and then w3svc1. For each of your websites, you're going to have a separate folder here for W3SVC1, 2, etc. They're all going to align with the different sites. So we only have one site, so we're going to do this one, and then we're going to look at the latest log that's out there. Now I'm going to blow this up full screen. We're going to talk a little bit about this log format. There's a bunch of great information in here. The first one is what date and time did this particular request occur? So this is essentially a list of requests that were made against the web server. The timestamp that the request was made, the server IP address that fielded the request, so which IP on the server side handled it. We've got a GET, so this is the different HTTP methods. We've got the URI stem here, so basically what was requested, upload ASPX, was requested over port 80, and this is the information about the client, so essentially whatever client requested. In this case, ::1 because it's localhost, but if this was adversary activity, this is going to be the adversary's IP address. Now note, and this is very important in security design. So if you have a network load balancer in front of your web servers, it's very likely that this IP address is going to be the IP of the load balancer. So this is why it's so important to have your logs offloaded from any sort of a load balancing device that you've got that might obfuscate the requesting IP address. You want to be able to trace this request back to the original requester. The next thing you have is the user agent string, which is a string that's used to tell the web server what type of a browser the client is coming from. Sometimes this could be a very good forensic artifact, especially if the attacker is using either a dedicated tool that doesn't mock a legitimate user agent string, or if they're using a strange browser that not everybody else is using. This is a way you can trace their activity between requests. This plus the IP address is usually pretty good. The last couple of columns we got over here on the right is we've got 200, which tells me it was successful. This is the HTTP response code. And the very last one is time taken, which is how many milliseconds it took to field that particular request. You're going to have one of these blocks every single time the web server is restarted. If you remember, we started out as the default identity, and then we changed to system. So we had to do an IIS reset. This is the IIS reset. Down here, this is all stuff happened after the IIS reset. So let's look at some of the differences. The first thing that's interesting here is get of hello.txt. Now, if I know hello.txt is not part of my default web code, this is already something potentially suspicious. It's telling me that somebody had the ability to upload something and then request it. Again, it really depends on the type of web server and the web application you're dealing with. But that's an indication right there that something might be awry. The next thing is we've got an upload followed by ASPX shell.aspx. This is yet another page that was not part of our default code. Now, the first time you get a new ASPX page, it has to compile some stuff on the server side. If you remember the CSC call that we saw in Defender. This is going to take a little bit longer. So that took 4824 milliseconds. Potentially interesting right there, telling me that the first time it was requested, it had to compile its code essentially. And that's an indication we may have Webshell activity going on. Next, this is pretty obvious with the URI stem. If you look at the fdir, this is basically saying, this is C Windows. We're going to see inetpub, www-root. These are all the different folder directories. If you remember, we changed the directories around, and then I told it to delete the www-root hello.txt. So this one is pretty straightforward. It's telling you what it's doing. The only reason why this works right now, though, is because we're using gets. If this was a post, you're not going to actually see that content. It's going to be hidden in the post back. So just because you don't see it as parameters in the URI stem does not mean it's not running active code. But what you can look at is on the right here, depending on the web shell, you may see additional time taken to execute. So that's something else to look for, is if you see something taking significantly longer than the rest of the content, that might be another indication that you may have a web shell on your box. So last, we got to talk a little bit about cleaning things up. How do we get rid of a web shell? There's a few options you've got available to you, but essentially the goal is going to be to first identify how the shell got there. Did it come from a vulnerability? If so, patch that vulnerability. If you have the ability to reduce the permissions of the IIS instance or the web server's identity, do so. This will prevent future web shells, the attacker basically coming back and dropping a new web shell. The other thing you may see with a web shell is attackers will sometimes use them as secondary persistence mechanisms to provide some durability. So they'll use, instead of using a vulnerability in the web application, what they'll do is they'll use the fact that they've got a strong enough identity inside the enterprise to do an SMB connection over to the web server and then copy it straight to that web publish directory. If that's the case, identify if you have any indication that somebody copied it from internal. If so, you need to address that issue as well as the web shell around the same time. Otherwise, the attacker can pivot from one to the other. Essentially, cleaning up a web shell is basically deleting all the web shells. The best way to do it is to diff it against your web content if at all possible. Republish if you can to clean up all those directories. Our best recommendation, though, is if you did see a web shell, you don't necessarily know if the attacker performed some additional persistence, i.e., did they use that web shell to install another piece of malware. So the best way to clean up a web shell is to rebuild the web server. That's the only real way that you're going to guarantee that you've gotten rid of any persistence, at least on that particular device. You also want to look for the potential impact of the identities. So, for example, if they were running as a user who had admin, you may want to take a look to see if there's any suspicious activity in, for example, Active Directory. Is there any backdoor user accounts or suspicious group changes that have happened around that time? Anything you can do as an adversary using an implant, you can essentially do using a web shell. So that's all I've got for you today. Thank you for watching my video. If you want more to see more content like this, please like the video and subscribe below. And happy hunting, everybody. I'll see you again soon.